Okay, now let's take a look at example 3. Before, when we were looking at RC circuits, like in the part 1 packet, we had things charging to either 0, the current was always going to 0. It was either charging or discharging. But in this case, in example 3, we now have a little bit more of a complicated circuit. And so over time, notice the current can bypass the capacitor. So if this capacitor gets totally charged up, there will still be current going this way. But our principle still works. Initially, the capacitor acts like a wire. So when this switch is first closed, all of the current will go through here. The current will bypass this because current would rather go through a wire than through a resistor. So this acts like a wire. And then after a long time, this is like an open switch. So after a long time, the current is going through here. And there's 0 current effectively through this. Okay. So what is the question asking about? It says, what is the current? So at time 0, what is the current in R1 and R2? So at t equals 0, the current going here through R2 is 0. All right, so that's the answer to question B, I think. The current through R2 is 0. Okay, so that means that all of the current initially will be going through R1, which is 20 kiloohms. So the current through there will be V over R, which is 30 volts over 20 kiloohms. So that's 1.5 milliamps. And then C asks, what is the current in resistor 2 a long time after? Right. So now a long time after, this is like an open switch. All the current is going through here. So the current a long time later will be V over R1 plus R2, because now I have current going through these two resistors that are in series. And this is how I get the effective, the total resistance for those two. And so this ends up being 30 volts over 30 times 10 to the third ohms. So this ends up being 1 milliamp. That's 20. This is 10 kiloohms. Okay. Now we have an extension question. What is the voltage across the capacitor a long time later? Right. So VC as time goes to infinity. Well, quick way to answer this. The voltage across this has to be the voltage across this resistor. These two things are in parallel with each other, right? If this is the plus, the minus side, the plus, the minus side of the resistor, plus, minus side of capacitor. If you go from one end of the resistor to one end of the capacitor, you get the same charge, plus to plus, minus to minus. These two are in parallel. So the voltage across this here is R, IR. So here's I, here's R. So 1 milliamp times 10 kiloohms would give you 10 volts. So if there's 10 volts across this, there's got to be 10 volts across this a long time later. Okay, and that means then there would be 20 volts across that resistor.